It's 2 o'clock in the morning on a Saturday afternoon. It's gorgeous outside. And I'm still recording videos for you. And 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 all of you. And all of you. I hope you're enjoying yourselves being in my absence. Old Kraus over there? Is he awake? I'm not even awake. I need a nap. Even the coffee's not helping. I think I finished this. I just polished off like this cup. It's empty. So I got to have a little energy left for you. So here we go. Geometric sequences. Geometric sequences. They're a little bit different than what we did yesterday. Not much. Not much. You shouldn't find these too difficult. My name is Mr. Kraus. I'm here to instruct for you today. I'm not old Kraus. I'm young Kraus. And we're going to be doing geometric sequences. Did I say that already? I might repeat myself like 6 times today because, well, like I said, I'm a little tired. So geometric sequences, unlike yesterday's, is we're looking for a common ratio. And you remember if we got ratios, we're really dividing. Yesterday we were adding and subtracting in order to find out what the common differences was. Now we're looking for a common ratio. And a ratio is really just a fraction. So in this case, yesterday we did R2 minus R1, correct? Well, now we're not going to do that. Since we're looking for a ratio, we're going to do R2 divided by R1. Or in this case, 27 over 81. Is that equal to 9 over 27? Is that equal to 3 over 9? Does that equal 1 over 3? This is certainly 1 over 3. This is certainly 1 over 3. And you may not know this, but 27 over 81 is 1 over 3. So these all have the same common ratio. Therefore, they are a geometric sequence. Over here, we got 2 over 1. That's 2. Then we got 6 over 2. That's 3. And then we got 24 over... no, not a geometric sequence. They have to have a common ratio. Okay, so yesterday... in arithmetic sequences, what we were doing was adding and subtracting. Now we're going to look for a common ratio raised to an exponent. So in this case, it's the first term, the common ratio to the exponent. All right, so the first thing we got to do is find out what the common ratio actually is. So 20 divided by 4 is 5. 100 divided by 20 is 5. So there's a geometric sequence here. And the common ratio is 5. So my R value is 5. And I really should write this work down, especially if I want full credit on the region exam. My A sub 1 is 4. So now you come back up. I should have had that equation up there for you. You're going to write the equation. A sub n is equal to the first term R, parentheses, don't forget the parentheses. It gets real ugly when you don't. 5, my common ratio, raised to the n minus 1. And then I want to find a sub 7. Now this one, the nice thing is I don't have to simplify this. I just want to find a sub 7. So I go, okay, a sub 7 is equal to 4, parentheses, 5 to the 7 minus 1, or 6 power. Come over here. I go 4, parenthesis, 5, parenthesis, raised to the, and I'm going to just raise it to the 6th power, 62,500. 62,500. 'Tis all, my friends. I really don't like this problem. Should have done a different problem. But just to show you that they can get obnoxious, R2 is negative 75 over R1, which is 152. It actually doesn't reduce. So there's my R value. Woohoo! And my A sub 1 is 152. All right. I still can do this. Let me write the equation. A sub n is equal to A sub 1, 152, parentheses, the R value, negative 75 over 152, raised to the n minus 1. And again, I want to find the 7th, so I do A sub 7 equals 152. Now, your calculator is going to give you a decimal here. That's okay, because there's no way this is turning out to be any fraction that I can use. 7 minus 1 is 6 again, so we'll put that in. 152, parentheses, control division, negative 75 over 152 raised to the 6th power. 7 minus 1. Oh my gosh, that gave a fraction? I don't want that. Let's figure out what that is as a decimal. I think it's 2 point something. 2.19. That sounds good. 2.19. I can't even believe they gave you that fraction. That's the salary. And I have no idea what that is. That's a huge number. It's like 2. All right, let's keep going. Common ratio. Ratio is going to be 15 over 3, which is 5. 75 over 15 is 5. 375 over... So we're going to do the same thing. Our a sub 1 is 3. Write it out. Get full credit. So my a sub n is equal to my a sub 1, which is 3, times 5 raised to the n minus 1. I still want the 7th, so I'm going to figure out what that is. 3 to the 5 to the 6th power. So I'll do 3 parenthesis 5 parenthesis raised to the 6th power. 46,875. 46,875. Gets big quick, right? Uh-oh. Whoa, whoa, whoa. What's going on here? Got a little something backwards. They're going to give us the 6th term. They're going to give us the ratio. They pretty much gave us everything. I think what they want us to do is recreate the equation. So we still want to write the equation. So I want to get to a point where I have a sub n is equal to a sub 1 parentheses r to the n minus 1. Well, let's see what I got. I have a sub n. That is negative 96. I don't have a sub 1. I do have my r value, 2. I also have my n value because my n value is just this 6 right here. So 6 minus 1, which is really 5. Or 6, I just wrote down 5. 6 minus 1, right? And that really is just 5. So if I get that in my calculator, 2 raised to the 5th power, I believe it's 32. There it is. So what I got is negative 96 equals a times 32. Well, to find out what it should be a sub 1 is, I just divide by 32. And I find out that a sub 1 is negative 3. So I'm almost done. I go, okay, a sub n equals negative 3, parentheses, 2 raised to the n minus 1. That's it. Let's see, one term of a geometric sequence is A4. A4. And the common ratio is 2. You know, there's another way you could do this problem to figure out, because really all I need, really what I want is I need a sub n equals a sub 1 r to the n minus 1. Well, let me copy it. Let's see. I want to eventually have a sub n equals, I don't know what this is, 2 to the n minus 1. So my goal is just to find a sub 1. I could say, oh, okay, there's 4 terms. This is a sub 4. This is a sub 3. This is a sub 2. And this is a sub 1. And I could come through and say, oh, you said this was 12. If the common ratio is 2, to go backwards, I'm going to divide by 2. So this would be 6. Divide by 2, I get 3. And divide by 2, I get 3 halves, or 1.5. So that looks like it's my a value. Or I could do it like I did before. I could say, okay, I know what a sub n is. That's 12. Is equal to a sub 1 times 2. Now, in this case, my n is 4. So 4 minus 1 is 3. So you all know 2 cubed is 8, right? So I'm really just going to divide by 8 here and divide by 8. And I get a sub 1 equals 3 halves. So there's my equation. So there's 2 different ways of doing the same problem. Uh-oh. Little review for you. What's next? Recursion? All right. We'll see. Let's see. 12 math test scores. Received the following test grade. I'm going to leave these for homework. These are part of your homework. I want you to do these homework. You'll do these in homework in class. So I'm going to leave these for you. So I'm going to get to the recursion notes, and then you're going to come back to and do these for homework. So this is part of your homework. Get her done. Get her done. Recursive sequences. Recursion is a process for choosing a starting term and repeatedly applying the same process to each term to arrive at the following term. Recursion requires that you know the value of the term immediately before the term you are trying to find. So if I had the 10th term and I knew the sequence, or I knew the recursive formula or equation, expression, then I could find the next term. So the starting value, again, will be a sub 1. But you'll notice that my next term, my recursive equation, will always use the one a sub n minus 1. So let's kind of see what that looks like. It's not that difficult. It sounds kind of complicated, but it's not too difficult. So I want to find the next 4 terms. So I know a sub 1 is equal to negative 4. I want to find a sub 2. Well, a sub 2 says we're going to go, all right, that's going to be a sub 2 minus 1 plus 5. Well, what is 2 minus 1? It's 1. So it's saying really, oh, a sub 2, take a sub 1 and add 5. Well, a sub 1 is negative 4, and we're going to add 5, which gives me 1. And then a sub 3 says, so you can't directly, this is not an equation, this is not like an arithmetic sequence equation where you can just get directly to the answers. You have to know the one prior. So in this case, a sub 3 is equal to a sub 3 minus 1 plus 5. Well, 3 minus 1 is 2. So a sub 2 we just found out to be 1. So that would be 1 plus 5, which is 6. And then a sub 4 says use a sub 3, which is 6, and add 5, which is 11. And a sub 5 says take the one before, 11, and add 5, and I get equal to 16. And that's recursion. Take the previous term and do something with it. But you have to know what the previous term is. So you have to know what a sub 1 is in order to do this. All right, let's take a look at this. This one's going to be a little bit more complicated. Let me get a different color because it's more complicated. Makes no difference. So I know a sub 1 is 3. Now I want to find a sub 2. So in this case, n is equal to 2. So this is equal to negative 1 squared. That makes it positive. You'll notice that when I get the cubed, it'll be negative. So every other term is going to be positive or negative. 5 times a sub n minus 1. Well, a sub n minus 1 is really this term because n is 2. And 2 minus 1 is 1. So that's this term. So this becomes negative 1 squared is 1. Times 5 times 3, which is 15. So the answer is 15. So now n's 3. Blah, 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 blah. Can't speak English. I got to write smaller now. A sub 3 is going to be equal to negative 1 cubed. That just means negative, right? Negative times negative times negative is negative. 5 times the one before, 15. So that's 5 times 15 is 75, times negative 1 is negative 75. Oh, I went too far over here. A sub 4 is equal to negative 1 to the 4th. Now, odd, it's an even exponent. That means it's going to be positive. 5 times negative 75. And 5 times negative 75 is, let's see, 4 is 300, so negative 375. And then a sub 5 is negative 1 to the 5th. Okay, so that's positive. Oh, that's weird. So let's see. 5 times negative 375. So it's negative times negative, so I know it's going to be positive. I have no idea what it's going to be. So 5 times 375. 1875. So my answer is 1875. All right, let's move on. Oh my gosh, ooh, what are all these? Oh, it's going to get funky. Let's go. A sub 1. Let's see. A sub 1 is 1. I want to find a sub 2, a sub 3, a sub 4, and a sub 5. Let's see. So this is equal to the one previous, which is 1, plus 3, which is 4. And this is equal to the one previous, which is 4, plus 3, which is 7. And the one previous, which is 7, plus 3, which is 10. And the one previous, which is 10, plus 3, which is 13. Whew, tough. This one is, so we got a sub, in this case they're going to give us a sub 0 is 4. I want to know a sub 1, a sub 2, a sub 3, and a sub 4. And in each case it says take 2 and multiply by the one before it, the term before it. 5 times 4 is 8. 2 times 8 is 16. 2 times 16 is 32. And then finally 2 times 32 is 64. So just keep plugging the one in before. That's recursion. Not too difficult, huh? All right, we'll get a few more in. I won't do them all. Let's see if I can find a tricky one. That one's pretty easy. Let's try this one. This one's a little funky. So a sub 0 is equal to 3. They just give it to us. Now I want to find a sub 1, a sub 2, a sub 3, and a sub 4. So a sub 3 is going to be a sub n minus 1. That's the previous term, minus n squared. 1 squared. So this goes here. Well, 3 minus 1 squared is just 1. So 3 minus 1 is 2. So now it's going to say, all right, you're going to take the previous term and you're going to subtract off n squared. In this case, it's 2 squared. So put in a 2 from before. And then 2 minus 2 squared. 2 minus 2 squared is, that's 2 minus 4, which is negative 2. So now I'm going to take the previous term, subtract off n squared, which is 3 squared. And we'll plug in negative 2 here. So negative 2 minus 9. Negative 2 minus 9 is negative 11. And finally the last one, negative 11 minus 4 squared. Well, 4 squared is 16. So negative 11 minus 16 is negative 27. Funky. We'll do 8. So a sub 0 is 4. A sub 1, a sub 2, a sub 3, a sub 4. So it says take the previous term, square it, and subtract 10. So if I take that previous term, plug it in, that's a sub n minus 1. That's 16 minus 10, which is 6. Then I'm going to take that previous term, square it, and subtract 10. That's a 6. 6 squared is 36, minus 10 is 26. Take that previous term, 26, square it, subtract 10, And that's one I don't have memorized. 26 squared. 676. I should have known that one. So 676 minus 10 is 666. Did I just write that? Does anybody else feel like, oh, all right, so it's there. Got to take it off. I'm not even that superstitious, bud, or crazy or religious or anything like that. Not crazy, like crazy religious. I'm just not that crazy. That just bothers me. I don't know what it is about that number. I think it's ever since I've seen the Omen that number bothers me. So that number was what it was 3 6s. And we're done with this problem. I'm done. Forgot that was in this problem. Actually, I don't even remember doing that problem, so I might have made a mistake. Let's see if I made a mistake. 4 squared is 16 minus 6, so that's 36. 36 minus 26 and 5. Oh my gosh. I shouldn't have picked 11. All right, two last ones, and let's get out of here. Let's get these hard ones in. So I'm going to give you a sub 1. We're going to figure out what a sub 2, a sub 3, a sub 4, and a sub 5 is. Sometimes my a's look like 9s. They told us this was 2. So what are we doing? We're doing n squared, so that's 2 squared, plus 3 times n, which is 3 times 2, minus the one previous, 2. So this is 4 plus 6, which is 10. This is 8. Then we're going to do 3 squared plus 3 times 3 minus the one before. So that's 9 plus 9 is 18 minus 8 is 10. So now we're going to do 4 squared plus 3 times 4 minus the one before. So that's 16 plus 12 is 28 minus 10 is 18. Do you see a pattern? I think the next one's going to be 26. Maybe not. 5 squared plus 3 times 5 minus 18. 5 squared is 25. 25 plus 15 is 40. 40 minus 18 is 22. That's weird. Thought we were going up by 8s every time. That one by 6. That one by 2. That one by 8. That one by 4. I don't know. Whatever. There it is. All right, let's try it. We're almost done. A sub 0 is equal to 2. A sub 1 is equal to 4. A sub 2 is equal to a sub 1 minus a sub 0, because this is n minus 1 and this is n minus 2. So this is equal to 4 minus 2, which is 2. And then a sub 3 is equal to a sub 2 minus a sub 1. A sub 2 is 2 minus a sub 1, which is 4, so that's negative 2. And then a sub 4 is equal to a sub 3, that's minus 1, minus a sub 2, that's minus 2, and a sub 3 is negative 2, minus a sub 2 is 2, that's negative 4. Final, last one, here we go. A sub 5, I don't care if it's the last one or not, we're doing it anyway. It's a sub 4 minus a sub 3. Well, a sub 4 is negative 4, minus, we'll be careful here, a sub 3, which is negative 2. So this is negative 4 minus negative 2, that's plus 2, so this is negative 2. And that's it, kids. That's recursion. Recursion uses the one previous. Arithmetic sequences, they just give you an equation and you basically just can plug in. But if you're doing recursion, you got to find out what what number is before, and the number is before, and the number is before. So you use the previous term to generate the new sequence. That's it. All done. Day 4, I believe. Day 4. All right. Goodbye, guys. Having fun storming the castle. Hit subscribe, please.